Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Products of Parity by MD88 Keys, or as I like to call them, Dr. Piano. And here are the rules. We have normal Sudoku rules apply, which means, in every cell in the grid, place a single digit from 1 through 9 such that every row, every column, we will get a row here, every column, and every designated 9-cell region, which in this case is a box, contains the digits 1 through 9 once each. I'm trying this way of saying things so that you can sort of think of different ways of understanding the normal Sudoku rules, because there are certain variants that sort of flip things a little bit, and it's only slight changes if you think about it. Anyways, I'm trying this out, and that is normal Sudoku rules in another way. We have also parity lines, where digits on a red line alternate parity, which means that it's odd and even. And parity is basically... Why is it called parity? I'm not sure. We've always known, so I know why it's called parity lines, but I don't know where parity comes from, actually. The derivation of why it's called parity between odd and even. And it specifically comes from zeros and ones, which is how you designate things in computers, where basically you either have a bit that's on or it's off, and that's how you essentially establish parity, right? If it's on, it's even parity. Sorry, if it's on, it's off parity. It's odd parity because it's considered on, right? A 1. If it's off, it's 0, which is even parity usually. But I don't remember why parity, where the term parity came from when designating that. Anyways, on a parity line, you'll alternate between odd and even digits. And that's all it means. Also, the red lines are also product arrows, where the product of the digits on a red arrow outside the cage multiply... okay, which means, okay, so the product of the digits on the red arrow outside the cage, which means multiply all digits, it equals the 2-digit number on the red line inside the cage, which you have to read left to right or top to bottom. So that would mean digits in a cage sum to the total given. So each red parity line has a cage that it's involved with, and the digits inside the cage form a 2-digit number. The leftmost, if it's going left to right, the leftmost is the tens digit and the rightmost is the ones digit. If it's going top to bottom, the top digit in the cage is the tens digit, and the bottom digit is a ones digit. So as an example, you could say have 2, 7, and 9 and 3. And this would be valid as a product arrow, because the digits outside the cage on the arrow, 9 and 3, multiply to the 2-digit number that is represented in the cage, which is 27 here. Again, 2 is the tens digit, 7 is the ones digit here because it's the left and the right. So therefore, 3 times 9 equals 27. And that's an example of how product arrows work. I've never actually seen this before, so this is my first time trying that. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. The one that comes to my mind first is this 17 here. There's only 2 unique digits that can ever add up to 17. sorry, one set of 2 unique digits that can add up to 17, and that's 8 and 9. So this is either 89 or 98 as the product of this. Well, the thing is, 89 is prime. So 89 could only be 1 times 89 to get a product. So this cannot be 89, it has to be 98. 98, if you break it down, if you factor it down, it's, I think, 7, right? So you have a 7. So 98 divided by 7 would give you 28 as a remainder, and then 14. So it'd have to be 14. So it'd be 7 times 7 times 2. That means you must have 2 7s on this arrow. So it has to be here and here, because if it were here and here, there would be a duplicate in the row. And this must be a 2. So we know this is 98727. So 7 times 7 is 49 times 2 is 98, and this is valid. To add 2 digits together that are unique to add up to 15 without a 7, so the possibilities were 6, 9, or 7, 8. But there's a 7 already in the box, so this has to be 6 and 9. 6 and 9, if you factor it out, it can only be 3 times 23. 23 is obviously not a digit, so that doesn't work. So this must be 96 to multiply together. Let's do the 11s. Those are interesting also. So you have 2 digits which are in the same row or column, I should say, or box as the 11 digits in the 11 cage. So to get this multiplication, you have to have 2 digits which are not the same digits as the digits in the product multiply to that product, right? And this can be 22 and 9. So the digits add up to 11 are 2, 9, 3, 8, 4, 7, 5, 6. And I guess we just have to go through each of those possibilities to see which ones can and can't be there, right? Hmm. 29 is prime, so that's not allowed. 92, if you divide, okay, so 92, obviously you can divide by 4. 92 divided by 4 is 20, that would be 6, 9, 12, 23. So 4 times 23 is obviously not going to work because 23 is prime. And so 23 can't be a single digit, so it cannot be 2, 9. Can it be 3? 83, I believe, is prime. Yeah, 83 is prime. 38 is 3 times 8. Which is, 38 is 2 times 19, which is 19 is not a single digit. So 3 and 8 don't work either. 5 and, this can't be 4, 7, but can you have, okay, so 47 is prime also. 74 is divisible by 2, and that gives, it's 2 times 37, which is also prime. So it's not a single digit. So that means this has to be 5 and 6. And if you have 65, the problem is it has to be 5 times 13, which 13 is prime. So that's not possible. So it has to be 56. So this is 5 and 6, and this is 5 and 6. 5 and 6 multiplied together, or 56 can be multiplied together by 7 and 8, and it has to be 7 and 8. So this is a 7-8 pair. This is a 7-8 pair. This 7 eliminates 7 here, so this is 8, which makes this 7. This 8 eliminates 8 here, so it's 7 and 8. Okay, so 7 times 8 is 56. So that satisfies both of those. Interesting. So to add up to 9, you have 1, 8, 2, 7, 3, 6, or 4, 5. Also, the remaining digits in column 9 have to be 1, 2, 3, 4, and 9. So these all could be 9. This is 1, 2, 3, 4, or 9. This is then 5, 6, 7, 8 to multiply to be the product, essentially. So it's 81, 72, 63, or 54. Oh, those are all going to be quite possible combinations. So all the 9s cages can be possible, right? You have 18, 1, 8, 27, 2, 7, 36, which is multiplied by many things, 45, 54, 63, 72, and 81. All of which are actually multipliable. Oh, this is 96 also. What is the factorization of 96? Probably quite a bit. 96 divided by 4, that's, I think, 24. Yeah, 16 is the remainder of 96 divided by minus 80. And 16 divided by 4 is 6. No, it's, yeah, 24. So 4 times 24, which is, if you factor that, 4 times 24, that's 1, 3, I believe. So 3 and then 8. So 3 times 2 to the 5th, I believe. 2 to the 5th is 32. Times 3 is 96. Yeah. So you have 1, 3 in one of these digits. And you have 2 to the 5th power. What you cannot have is a 5 here. So one of these two digits is a 5. These digits are 1 through 4 and 9. You cannot have a 9 on this arrow either. Because if you had a 9, the problem is that that's 3 squared, and 3 squared is not part of the factorization. This can't be 9 because of the 9 in the column, so where's the 9 in this box? It has to be here. So 5 has to be one of these two. Interesting. The remaining digits in this lower central box are 1, 4, 3, 1, 3, 4, 5, 8. 8 cannot be either of these. 8 can't be here. We are guaranteed, and this can't be 5. We are guaranteed an 8 here. So that means we only have 2 squared and a 3 left. Well, if this was 3, 4, and 8, that would already multiply to 96, and this can't be 1 and 1. So this cannot be 3, 4, and 8. We are guaranteed a 1 here. Say we didn't have a 1 here. What is the minimum this would be? I think it's 2 and 3. And the problem here is this is at minimum 1, 3, and 8. So 24 times 6 is already greater than 96. So this is guaranteed to have a 1 here, which means this cannot be 1. This can never be 2, because that would require a 2 and an 8 here to multiply together, or a 4 and a 4, or some sort of possibility like that, or a 6 with something. But we don't have a 6 or 2 available, so this can never be 2. So this is 1 with 3 or 4, and this is 1 here with 3, 4, and 8. So 8 is guaranteed here. We don't know if the 3 or 4 is. So this is guaranteed to be 1. What does this multiply to? So we can have 129, which multiplies to 18, but that's not possible as a digit here. We can have 139, that's 27, but again, you can't multiply together to get that anything. I think you're guaranteed to have a 1 here. If you have, no, you could have 239. Okay, so never mind. These two digits cannot be 5 and 4 or 3 and 6 adding up. So this is 1, 8, or 2, 7 in some order. What else do we have? Yeah, let's keep doing this. So 149 is not possible. So you can't have 129, you can't have 139, you can't have 149. I think you have to have a 9. Do you? Maybe not. No, yeah, if you don't have a 9, this is 2 times 3 times 4 at most, which equals 24, which this can't be. So you have to have a 9 here, guaranteed. So this cannot be 9 here. We're guaranteed a 9. You can't have 129, 139, or 149 here, so 1 is not allowed. 239 would mean it multiplies to 54. 249 multiplies to 72, but you're guaranteed a 2 here, so this can't be 2 then. They can't have 72. 349 multiplies, it's too big. It's not a 2-digit number. So it's 12 times 9, which would be 100. No, so 12 times 9, that would be 90 plus 18, so it's 108. So that obviously doesn't work. So this must be 2 times 3 times 9, which multiplies to 54. So that's 54. This is a 1 then. We have 2, 3, and 9 here. This cannot be 4 and 5 because of the 4, 5 pair in the box. So it could be 1, 8, 2, 7, 3, or 6. Remaining digits in row 4. We have 1, 2, 3, 4, 6, and 9. 6 cannot be here because of the 6 in the box. This can't be 6 or 9 because of the 6 or 9 in the column. This can't be 2 because of 2 in the column. What are these multiplied together? If you don't have a 9, it's 3 times 4, which is 12, which is not possible to be in this cage. So this has to be 9 here, which eliminates 9 in the rest of the row and box, or just row in general. 9 times 1 is 9, so this can't be 1. 2 times 9 could be 18, so that works. 3 times 9 multiplies to 27, which works. 4 times 9 multiplies to 36, which also works. Okay, again, this has to be 1, 8. If it's 2, 7, this is 2, and that's 7. If it's 3, 6, this is 3, and that's 6. If it's 4 and 5, this is 4, and that's 5. One thing, so this cannot be 9 times 9. This can't be 9 times 9. So this cannot be 81. So there's no 81 here. 4 and 5 would require 5 times 9, but this can't be 5, and this can't be 5. So that doesn't work. 36 would require 4 times 9, or 6 times 6, but you can't have 2 6s in the same column. So it could be 4 and 9 there. 27 requires 3 and 9, so that could work there. So again, the possibilities are 3 and 6 is 4 and 9. And again, we have to have a 9 be one of these two digits. 27 is 3 and 9. So this would have to be 3 and 9. 18 would be 2 and 9. So this is 2 and 9. So this is guaranteed to be a 9 here. So this is 9, which means this can't be 9, which means 9 has to be there. Again, you have 1, 8, 2, 7, 3, 6, and cannot be 4, 5 because of 4, 5 in the row. This can't be 8. This can't be 8, so this can't be 1 and 8. This can't be 7, so this can't be 2. So you have 36 as a possibility, which could be 6 and 6, but this can't be 6 because of 6 in the column. So it would have to be 9 and 4 if that's the case. 63 would have to be 7 and 9 to multiply together. So this is 7 with 9. And 72 would have to be 9 and 8 as 2 digits. And this has to be 9 here. So this is guaranteed to be 9 also. This cannot be 18. Can it be 27? I think the answer to that is no. So it cannot be, if it's 18, the minimum of these 3 digits is 2 times 3 times 4, which is 24. And then you multiply by some other digit, it can't be 18 or 27. So it has to be 81 or 72. Well, this cannot contain a 9, and these can't be 9. So can it ever be 81? And I think the answer to that is no, because you have to have four threes multiplied together. I guess you could have 6. Okay, well, 6 is eliminated here, too, because of the 6 in the box. So no, you can't have a 6 here. And even then, you have to have 6 times 3 in the same box here, and then 6 times 3 here, which is not possible. So it cannot be 81, it's 72. So this is 7, that's 2, which eliminates 7 and 2 in the rest of the row, and the 2 in the rest of this box. So this is 3, this is 2. This can't be 2 or 3, it must be 4 and 9 multiplied together. This can't be 4, and it cannot be 3. That makes this 2 and 3, 2 and 9. This can't be 1 or 2 or 3, so it's 1. This can't be 1 or 3, so it's 6. 4 and 9 multiplied together to be 36, so that's 36. 2 and 9 multiplied together to be 1 and 8, so this is 18. Or sorry, multiplied together to be 18, so that's 1 and 8. Whereas the 1 on this arrow, this product arrow, it has to be here. This can no longer be 8, so this cannot be 72. So it must be 36 here, or 63. We don't know which. This 8 eliminates 8 here. Where is the 8 in this lower central box? It has to be here. So this is 8. This one... This is 72. Okay. The factorization of that is 2 to the third and 3 squared. What we cannot have, though, is a 9 here, though. But we could have 3 times 6. So that is possible. What are the possible digits here? You have 1, 7, and 8 in this right central box. This can't be 7. This can't be 7. Where is the 7 in this box? It has to be here. In this upper right-hand box, what are the remaining digits? We have 1, 7, and 8. This can't be 7 then. We have a 1, 7, 8 triplet in column 7, which eliminates 1, 7, and 8 in the rest of the column. So this has to be what? No 1, no 2, no 3. It could be 4, 5, 6, or 9 here. And 9 cannot be either of these digits because of the 9s in the row. This can't be 6 because of the 6 in the row. This can't be 5, because if it were 5, 5 times another digit would have to end in a 5 or a 0 as a product. Remaining digits in column 8 are 2, 3, 4, and 9. Again, this can't be 9 here. Okay, this is at minimum 2 times 3 times 4. Which multiplies to 24. So this can never be 8 here. 8 times at minimum 24 is like 100 and something, and that's not allowed. So this is 1. Also, this 1 eliminates 1 here, so that's 8 anyways. This it can't be 8 because of the 8 in the column, so this is 1, which eliminates 1 here and 1 here. So this must multiply to 72 by itself. We need 3 squared, and we don't have access to a 9, so it must be 3 times 6 here, which is 18, and then we have to multiply by 4. Well, where is the 6 then? It has to be here. This is 6, and this must be a 3, 4 pair to multiply to 72. That eliminates 3 and 4 in the rest of the box. So this can't be 4. This is 5. This can't be 5, 6, or 4, so this is 9. This can't be 3, 4, or 9, so it's 2. Okay. This 3, 4 pair eliminates 4 here, so this must be 9, which makes that 4. Okay. Where is the 8 in column 3? Cannot be any of these cells because 8 in the boxes and these are filled, so this must be 8 here, which means this can't be 8. This is 7, that's 8. This 7 eliminates 7 here, so it's 4 times 9, which makes that 36. So that's 3 in the corner. We celebrate because we know we're getting close to solving it. This can't be 3 because of 3 in the column. So 3 has to be one of these two. Remaining digits in row 5 are 3, 4, and 9. This cannot be 4 because 4 in the columns can't be 9 because of 9 in the column. Remaining digits in row 1, we have what? 1, 2, and 7. And this can't be 1 or 7 because 1 or 7 in the column, so this is 2. This can't be 2 or 7, so this must be 1, which makes this 7. Okay, so this cannot be 1 here. Where's the 1 in this box? It has to be here. So that's 1. We have a 3, 4, 3, 4 pair in row 8, which eliminates 3 and 4 in the rest of the row. So that makes this a 1. This 4 eliminates 4 here. Remaining digits in row 3, we have what? 4, 5, and 7. This can't be 4, 7 because of the 4, 7 in the box, so this is 5. This becomes 4, 7. This can't be 7 because 7 in the column, so that's 4, that's 7. Remaining digits in the upper left-hand box are 2 and 5. Either of those could be 2 or 5. This 4 eliminates 4 here. Remaining digits in the upper central box are 3 and 6. 6 cannot be here because of 6 in the column. So this is 3, which makes this 6. 3 eliminates 3 here. Remaining digits in column 2. We have 2, 3, and 5. The remaining digits in column 3. We have 2, 3, and 4. So this is 3 or 4. That means this is 2, 3, or 4. We have a 3, 4, 3, 4 pair in column 3, which eliminates 3 and 4 in the rest of the column. So this has to be 2, which means this can't be 2. The remaining digit in row 9 with a 3, 4, 5 triplet means this has to be 6. This 5 eliminates 5 here, so it's 4, which makes this 5. This 4 eliminates 4 here, so it's 3, which makes this 4, which makes this 9. This is 3 times 8, which is 24, so that must multiply with 4 here. That makes this 3. That eliminates 3 here, so it's 5. This 5 eliminates 5 here, so it's 2 and 5. 2 eliminates 2 here, so it's 3. This can't be 4 or 9, so it's 2. 9 eliminates 9 here, so it's 3. Remaining digit, this 3 eliminates 3 here, so it's 4 and 3, which makes this a 4. This digit is a 9. We have a 5 here, and a 6, no, an 8 here. And that's the remaining digit. Yeah, this is... Oh, I didn't even look at the parity. I just completely ignored the parity and said, what did these have to multiply to get together to? I think the parity should work, right? Odd, even, odd, even. Odd, even, odd, even, odd. Odd, even, odd, even. Odd, even, odd, even. Odd, even, odd, even. Odd, even, odd, even, odd, even, odd. Odd, even, odd, even, odd, even. Odd, even, odd, even. They all start with odd. Odd, even, odd, even, odd. I didn't even take into account the parity of this. Yeah, you didn't even really need that. You just have the red line, right? You just have them as product arrows and just go through it that way. I just completely ignored the parity stuff. That could have made things easier, I guess. Yeah. Not necessary, though, interestingly enough. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.